Matrices part 7. Matrix is given 0 minus 10 alpha by 2, 10 alpha by 2, 0. And we have to prove that I plus A is equal to I minus A cos alpha minus sin alpha. So first we will find out I plus A. So as it is 2 by 2 matrix, so I will be 2 by 2 obviously. So I plus A, first see that what is the value of I plus A. I will be 1, 0 and 0, 1. And it is added with the matrix 0 minus 10 alpha by 2, 10 alpha by 2, 0. So we get left hand side 1 plus 0, 1, 0 minus 10 alpha by 2 minus 10 alpha by 2, and 0 plus 10 alpha by 2, 10 alpha by 2, and 1 plus 0, 1. This we have to prove. This is our left hand side. Okay. Now we will take right hand side, that is I minus A into this. So first we will find I minus A. So I is 1, 0, 0, 1. Unit matrix minus A matrix. A is 0 minus 10 alpha by 2, 10 alpha by 2, 0. Added. Here we are going to subtract now. 1 minus 0, 1, 0 minus plus 10 alpha by 2, and 1, 0 minus 10 alpha by 2, and 1 minus 0, 1. This is I minus A. It will be multiplied with cos alpha minus sin alpha cos alpha. So therefore 1 minus A is multiply with the matrix cos alpha minus sin alpha sin alpha cos alpha. Substitute the value of I minus A. I minus A is 1, 10 alpha by 2 minus 10 alpha by 2 1. Multiply with cos alpha minus sin alpha into cos alpha. So first row, first column. First row, first column. So this will become 1 into cos alpha plus 10 alpha by 2, 10 alpha by 2 into sin alpha. Correct? First row, first column. Now first row, this is first row, R1, first row, second column. 1 into minus sin alpha minus sin alpha, 10 alpha by 2 plus 10 alpha by 2 multiply with cos alpha. Now we take second row, first column, minus 10 alpha by 2 minus 10 alpha by 2 into cos alpha plus sin alpha. Then second row, second column, minus minus plus 10 alpha by 2 sin alpha, and alpha by 2 into sin alpha plus cos alpha. Okay. Now 10 alpha, I will convert 10 alpha into sin alpha by 10 alpha by 2 will be written as sin alpha by 2 cos alpha by 2. Here also sin alpha by 2 cos alpha by 2. Sin alpha by 2 cos alpha by 2. Sin alpha by 2 and cos alpha by 2, and then taking LCM. So we get this sin alpha by 2 cos alpha by 2. So cos alpha into cos alpha by 2. There we get cos alpha into cos alpha by 2. After taking LCM, are you getting? And plus here sin alpha by 2 will be left. Sin alpha by 2 into sin alpha, and denominator will be whole divided by cos alpha by 2. This is the first element. Similarly, here also tan is converted into sin cos. So we get minus sin alpha into cos alpha by 2. Cos alpha by 2 plus sin alpha by 2 into cos alpha. And this whole term is divided by cos alpha by 2. Okay. Similarly, here again convert minus sin alpha by 2 cos alpha, or you can write cos alpha into sin alpha by 2 plus sin alpha cos alpha by 2, and whole term is divided by cos alpha by 2. Here we are just converting tan into sin upon cos and then taking LCM. Okay. So here you get sin alpha and sin alpha by 2. Sin alpha and sin alpha by 2 plus cos alpha and cos alpha by 2, and divided by cos alpha by 2. You can take common also 1 by cos alpha by 2. Okay. Then before space. After this is the formula: cos A cos B plus sin A sin B is equal to cos A minus B. So it will convert into cos A minus B. That means cos alpha minus alpha by 2, and denominator is written as it is divided by cos alpha by 2. Then come to this point: cos alpha sin A cos B minus cos A sin B. Sin A cos B minus cos A sin B, but minus, we should take out minus common, then it will become sin A cos B minus cos A sin B. Sin A minus B sin alpha minus alpha by 2 divided by cos alpha by 2. Similarly, here sin A cos B minus cos A sin B. Sin A minus B. So we will write first sin alpha cos alpha by 2. So it will become sin A minus B sin alpha minus alpha by 2 divided by cos alpha by 2 Similarly here, sin A, sin B plus cos A, cos B is equal to cos A minus cos A, cos B plus sin A, sin B is equal to cos A minus B. So cos alpha minus alpha by 2 divided by cos alpha by. So alpha minus alpha by 2 is equal to alpha by 2, alpha minus alpha by 2. We can take the LCM 2, so 2 alpha minus alpha, so alpha by 2. 1 minus half, half, so alpha by 2. So we can replace alpha minus alpha by 2 by alpha by 2. So this will become cos alpha by 2, cos alpha by 2. Cancelled 1, sin alpha by 2, cos alpha by 2 minus 10 alpha by 2, sin alpha by 2, cos alpha by 2, 10 alpha by 2, and here 1. And which is equal to I plus a left hand side, which is equal to I plus hence true. Okay. If you have a doubt, you can ask. Otherwise, I will go to the other question. If you have a doubt in any step, just you can ask now. No?
No, sir. No, sir.
Okay. This is question number 19. We are doing exercise 3.2. 3.2. A trust fund has 30,000 must be invested in two different types of bonds. The total investment is 30,000. So amount 30 will be divided into two bonds. So we don't know how much invested in the first bond. So let us suppose that X rupees were invested in the first type of bond. So the amount invested, let the amount invested in first type, first type of bond, rupees X. Then the amount invested in the second type of bond will be out of 30,000 X is invested. How much left? 30,000 minus X. So 30,000 minus X is invested in the second type of bond. And the first bond pays 5% interest per annum, and second bond pays 7% interest. So we can write first matrix which will show the type of bond is investment X and 30,000 minus X. This will be the row matrix, and 5%, percent means 5 by 100. When the percentage sign is removed, we have to write 100. So 5% and 7% of this is invested, both the bond, and the annual total interest is rupees 1,800. So it will be equal to 1,800. This is according to the given condition. Why we are taking this? This is having one row and two columns. It's having two rows and one column. So here we will get one by one. So that's why first will be row matrix, second will be column matrix. Now multiply and equate them. You will get the value of X. So multiply first row, first column finished. Only we have to multiply first row, first column. We'll get the matrix one by one. So x into 5, 5x by 100 plus second element 30,000 minus x into 7 by 100. So 7 by 100. This will be equal to 1,800. So now we got one by one matrix here. Here also one by one. So we can equate their elements. So we get 5x plus 7 3s are 21. 0. Okay. Minus 7x upon 100 will be equal to 1,800. So we get 5x minus 7x, 2 lakh 10,000 minus 5x is equal to 1 lakh 80,000. And 5x will be equal to 2 lakh 10,000 minus 1 lakh 18,000. 80,000 will be 15,000 divided by 5 to 3,000. We get x is equal to, no, this will be 30,000 and this will be 30,000.
So X
2x.
would be
Yeah, this
6,000.
will be 2x. So 2x will be equal to 30,000 and
Right.
x will be equal to 15,000. So both the bonds will have the same investment, correct? 15,000 is invested in the first bond and second bond also 15,000. Similarly, the second question you have to do, instead of 1,800, you will take 2,000. Same way. Okay. Transpose of a matrix. The matrix obtained by interchanging the rows and columns means rows will be converted into columns and columns will be converted into rows, obviously. So that is called the transpose of a matrix, and it is denoted by, it is denoted by A dash. Sometimes A dash, or in somewhere you will find AT also, but capital T, not a small t. Or sometimes AC also. So there are three ways of representing. For example, if A is a matrix of numbers 1, 5, root 2, 1, minus 1 by 5 and 0. So this is having 3 rows and 2 columns, 3 by 2. If we want to write the transpose of this matrix A dash, what we will do, first row will become first column. 1, 5 is the first row, this is R1. This R1 will become P1, first column, that means 1, 5. Second row, change second row to second column, root 2, 1, and change third row to third column. Third row will become third column, minus 1 by 5 and 0. Now its order will become 2 rows and 3 columns. So order will be interchanged. So like this we can find the transpose of a matrix. There are properties of transpose of a matrix. So properties of transpose of a transpose of matrices. First property is if you will find the transpose of a transpose is a matrix itself. Obviously, if you will again interchange, this is the transpose. If you will change, you will find the transpose of this matrix, then again this will become the first row will become first column 1 root 2 minus 1 by 5, 5, 1 and 0. So this will again become A. So transpose of a transpose is a matrix itself. Second condition for addition subtraction both, if you add two matrices and find the transpose or transpose of their addition and subtraction will be same. Either you find first addition and then transpose or first transpose and then add them. Means transpose of their sum will be equal to sum of their transposes. And similarly for difference also. Similarly, if one constant is multiplied with A and we want to find the transpose of this one, so there is nothing to do with K. K is a constant, so we have to find the transpose of matrix A dash, obviously. And this fourth property is very important when you are finding the transpose of the product of two matrices A into B. Transpose will be equal to B transpose into A transpose. The position will be interchanged. B will come first and A will come second. And one more property, if you have a matrix and you have 5 power or 3 power or n power, then you want to find the transpose. So you can find the transpose of the power of the transpose. First you can find the transpose and then power, or you can find the power and then transpose, where n is a positive integer. Okay, so this is the property. These are the properties of transpose of a matrix.